Hey guys, how are you doing? This is JSer who is not good at algorithms. Today I'm going to take a look at number 215, kth largest element in an array. We need to find the kth largest element in an unsorted array. Unsorted. Note that it is the kth largest element in the sorted order, not the kth distinct element. I see. So for example like this, we need to find 1, 2, kth 2 based on 0, right? So it's 5. Okay. And for case 4, so 1, 2, 3, 4, 5. Wait a minute. Kth largest. It's backward. Okay, my bad. So this case based on 1. 6, 5, 5. Okay, and K is 4. So 1, 2, 3, 4. So it's 4. Cool. Well, the idea, I think it's very simple. The first one, we just sort it and define the kth element, right? I think it's not acceptable. But first, let's try to see how fast we can get, right? We just sort first. This is not cool. And about the sort, remember that the k, the element is just could be anything, right? Only thing we know is that it's numbers, so we don't know the range. If there is a range, maybe we could do some counting, but there's no range. And so first, nums sort. Wow, this is really not cool. Minus a, and then return nums k minus 1. Wow, this is not cool. But we're faster than 85%, right? So let's analyze. We use the built-in sort. We need to see what the time complexity is. Okay, time complexity is what? The time is the sort, right? So for as n numbers, it would be big O on log n, right? This is the time complexity for sort. So we first sort them all and return the kth element. Could we do better? Of course, there's something that we could do, I think. If not, this shouldn't be a problem. But remember, we did the quicksort before. It's 912. If you haven't seen my video, haven't watched my video, please search on my channel for that. There's a detailed explanation of how we could sort array in bubble sort, selection sort, insertion sort, and quicksort. This is the quicksort, the last version. Yeah, please see that first. So the idea is simple. For quicksort, we pick a number at the left and then swap all the numbers smaller than it to the left and bigger than it to the right. And then finally, we move this number into the middle. So this element is actually sorted. It has the right position, and then we recursively sort to left, sort to right. Here you can see the implementation. For quicksort, we start and end, and we choose a pivot at the start and set the insertion index. Yeah, and then loop through all the elements. If it's smaller, we swap and then move the insertion point to the next one. When everything is done, we swap the pivot, right? The first number to the index, and then we recursively sort the others. What you see, if things go right, if like at the beginning, if the once we swap the pivot, we found that this is just right. The index, what would be? Well, it means we could just pick a number like 4, but without sorting all the array, right? We pick a number, but the left and right actually could be just left it like that. We don't need to sort them. So that's actually a very cool improvement of this quicksort solutions, right? I think this is called quickSelect. If you're interested, please search on the internet. And yeah, and here I'll just copy the code, or we not yeah. Let's take this chance as another way, is another problem to validate our ideas. Okay, so the idea is simple. Just a fast, short circuit with a quick sort, right? Yeah. Now let's do the quick sort. The idea is simple. We do it recursively. So quick sort, start, end. This is in place. Quick sort is in place. So we okay, I'll leave it later. Okay, so when we are going to sort the array from start and end, we choose the pivot as the start number, right? Yeah, and then if we find, like, choose this one, and if we find another number, what should we do? We should swap it with this one, so right? So let insertion index would be start plus 1, right? So we start okay, we start from 1. I will smaller than nums dot end I plus plus, right? We will check, we will compare the elements. If nums I is bigger, wait, we need to find the largest element, so we need to do the descending order. So if it is bigger than it, so if it is smaller than it, we move to right. If not, if it is bigger than it or equal to it, we do nothing, right? So it's if it's smaller than pivot, we need to swap, right? Swap the element with this insertion index, right? Like we found this one, and here's a number. You find this one, and well, itself. So because itself, we swap it. It doesn't matter. If we choose this one, like it's smaller than it. Wait a minute. It's wait a minute. Wait. We need to put the larger numbers to the left. So if we want to put some numbers to the left, it should be bigger than the pivot. Oh, sorry, I made a mistake. What happened is if it's equal to it. If it's equal to it, I think it still. Yeah, I think it still should move it, right? It means that when we swap it, the bigger ones and the equal numbers are to the left, so this should work. When we swap it, so yeah, this one is fixed. We should move the insertion index to the next one, right? When this loop is done, we get our goal, which means this like index is here, this is pivot, so the numbers here are bigger than it or equal to it, and this is smaller than it, and this index itself should be smaller than it. I think smaller. Yeah, smaller than it. So what we do? Well, obviously, we need to swap this pivot to the number between this insertion index, right? So if we do that, because the list here is bigger or equal to it, if we move this number to this last index, it will not affect the whole order, right? Like, yeah, so we swap the pivot, which is start, and the insertion index minus 1. Now, after we do this, there's a quick check. Like if this insertion index is just the target, right? So this number will actually be at the index, right? The pivot will be at that index. Cool. So we will just do it here with without swapping it before, without swapping it yet. I'll say let target it will be undefined. Okay, so if insertion index is equal to k, then the target, I'll say the target equals the pivot, and then I can return and do nothing. Now we swap it, right? Now if this is not a target, so we swap the pivot and do it recursively. We will quick sort the next one, right? So it would be start insertion index minus 2. Remember, quick sort. This is this, and insertion minus 1 will be fixed as this pivot. Cool. Now let's write the swap. ij. Well, this is pretty simple. Just don't forget that there might be some cases we don't need to do anything. If I equals to j, we just return, and const of temp equals nums I equals nums j equals 10. Cool. And finally, we return the result. The thing is that so this is not quick sort anymore, right? I think this is quick search. Select, I think, right? It's called quickSelect. Anyway, I'll call it quickSelect. quickSelect. Remember that if we do it recursively like this, the index is still based on 0 from this nums itself. So the check is of here should be valid. It should work. Let's try run the code. No, result is undefined. Target. Oh my god. My bad. Undefined. What? Like for this. For 2, the first we pick 3, right? So this is smaller than it. Not touch. So 5, 6, 4, all bigger than it. So we'll be 5, 6, 4. Let's do the review in our mind. 3, 2, 1, 5, 6, 4. After the first round of quickSelect, it would be 5, 4, 5, 6, 4, 2, 1, right? and then we need to swap this one. Swap these 3 and 4, but the k is 2, so it is not equal to our target. It is not what we want. 4, 5, 6, 3, 2, 1. Wait a minute. Actually, we could avoid it if left one is bigger than it, so we should search on the left one, right? We could improve more. So the index, if the index is bigger than k, which means k is to the left, we select this. For the other case, we select this. Okay, so it's index, this one is bigger than k. Oh, k is based on 1, my god. Shit, it should like this. Try it one more time. Still undefined. What? Okay. Okay, like this. Because k now, the index before our k is 2, so it's 1. It's to the left one, right? We now search on this. We choose 4 and 5, 6. I see. It's because if these are all sorted, there's no swapping thing. So like start would be 4, 5, 6. No, 4, 5, 6. We do it, and then the index will be here, right? So we swap it. So 5, 6, 4, 3, 2, 1. And now 4 is index of 2, still bigger than it. So we will start from this one. And 5, this is not changed. The pivot will start with 5, and the search index will be at 4. So it will be 6, 5, 4, 3, 2, 1. So the insertion index would be 4 here, right? 2 minus 1, 1. 1 equals k minus 1. So target should be the pivot. And then we return target. It should work, man. I think it should work theoretically, but I don't know. Console log nums. Shit. I know what is happening. I forgot to start. My god. Nums dot length minus 1. And I remove the lock. Cool. Submit. Maximum call stack size exceeded. Of course. I forgot add the ending cases. Which is start. If start is small, bigger or equal to end, then there's nothing we can sort. It's equal to it. We should do like this. Huh? It says undefined? What? So hey guys, could you see where I did it wrong? Okay, like this. First we got this. Oh, let's lock the index also. No, it's okay. Okay, I'll lock it here. And the insertion index -1. Okay. The first one is insertion. The swap index would be 4. 0, 1, 2, 3. Yeah, and then we quick select here, right? And this insertion the 0, 1, 2. Yeah, it's right. So we swap it and like this, and then we find, and then we start with 6 and 5, 4, 3. They are all smaller than it. So the insertion index is this. Ah, I see. So if it is already descending, it will be itself. So when it is itself, when it is itself, it means it's already sorted, right? Because there's nothing bigger than it, so it means it is the biggest one. Ah, this assumption is not right. It's not right. You see, for here we thought that it is in it. So yeah, it is in it. Now we swap it. So here it's 0. We select quick select start. Ha ha ha. So the if here is not right. If the index here is now 0, it's smaller than it, so we should see the 0, so we should start with insertion index is 1, right? And the end. So log select start and right. We select 1, 1. 1, 1. Ah, I see. We should not return when there is one. When there is one. We start with 0 and end at n. If start is bigger than n, then you should return start, because there's only one number there. Huh? Still undefined? Ah, not return. Really, I got a headache. Return nums start return. What's this? Maximum call stack size exceeded. Like this. So this is so for the fifth one. Okay, 3. We move like this. So the insertion index -1 would be 0. What? No, it's 5. Okay, and then we got 3, right? First one we move it so it's like this. And now we check 3 because we're searching for 4. This is 5, so there is a 5 number. A 6 number, yeah. So we need to search in this half, and then we're picking 3 and define move 4. Move yeah, these are sorted, and then we swap 6 with 3, and then it would be setting insertion index will be 0. What is wrong? What is wrong here? We swap it, but why index? Why index? It's hard. Programming is hard. Why it's we swap this 3 with this 6, right? Log swap pivot from start to yeah. Okay, it's from 0 to 5. This, right? So it become this, and this from pivot 0 to 0. Because it's the biggest one. Oh. Yeah. If we match the biggest one, left tab will not work. Yeah. So I think the insertion is if it's 0 and it is not what we want, then we just need to check the right, even if but k, but it's smaller than k, so we quickSelect insertion end, right? What is k minus 1? God, not here. Okay, because it's smaller than it, so we click select insertion, which is 1, and n. A lock here also. Select start and okay to 5. Okay, and then select 0, 4, 0, 1, 2, 3, 4. So select 1, 2, 3, 4. Well, it's right. And then swap pivot for 1 to 5. Then there's where is this 5? Ah, I know what happened. I know what happened. It should be in at end. My headaches. I think there is if there's only one, but only one number, this will still go on. So yeah, I think we can just return at this. It should work. Yeah, that's right. Let's remove the console log. Run the code again. Huh? Ah, this is not console. My God. Cool. Submit. Oh, finally, we're accepted, but we're not that fast, man. Really? Let's see if we could improve this. I think we're doing great, right? Pivot, and there's a loop. And then check it, and swap it, and recursively searching, right? I think we're doing great. Let's see if there are any other fast solutions. Oh, like this one. This one is very fast. Partition, pivot. So it's, I think they are doing the same. It's quickSelect. I don't know why we are slow at this one. Start. Let's first analyze our time and space complexity here. Space, nothing. Is it because of swapping? No. Okay. Time. It's basically for the worst case. Well, for the worst case, we will actually for the worst case. Okay, every time we just filter happen to filter only one element, and just we want the last element, so it's kind of the worst case. Well, if it is already sorted, so this will cost us actually every time we will loop through all the elements and just reduce one, so actually it will be O square, worst case. So averagely, at every time we can cut half of the elements, right? So and Yeah, so averagely would be O. This will like firstly will be n minus 1 plus n minus 1 divided by 2. And then n minus 1 divided by 4. So its generator should be n times 1 plus what's this? It should be well, what is this? Should be let's analyze what is 1 plus this plus until what? Until there is only one element, right? So that means it would be how should I add some of this up? Okay, n plus n divided by 2 plus n divided by 2 plus n dot 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 n divided by n log, when it is 1, so it's log 2n, right? It should be what? It should be let's say let's try to calculate the this, right? Let's save it to s and then we divide it by 2, so it will be like this, right? Plus 1 plus, it will become like this, and one more, 1 divided by 2 times power of n plus 1 equals s divided by 2. Now let's subtract these two formula. It would be 1 minus 1 divided by 2 right? So we get s actually equals 2 divided by 2 something like this, right? And then we times n to n minus n divided by 2. Okay, so we know it. So the average of this should be linear time, right? This could be very small when n becomes very big, so we can remove it. And the space would be about space. Actually, it seems to be linear time, but actually there's no return of this quickSelect, so would be no call stack of this problem. Actually, it's tail recursion, and yeah, so the space could actually be constant. Okay, so that's all for this problem. Hope it helps. See you next time. Bye bye.